Welcome to the deep dive, where we slice through the noise, take a stack of information, and really extract the most important nuggets of knowledge or insight. We want to give you that shortcut to being truly well informed. Today, we're diving into something absolutely foundational in our data-driven world: performance optimization in Oracle Database 21c. Specifically, we're zeroing in on query tuning and indexing techniques. Our source material for this, it comes from some insightful excerpts from Oracle 21c Performance Tuning, Queries and Indexing, which was written by Angela over at Sunshine Digital Services. Our mission today is really to unpack why database efficiency can literally make or break your application performance. And, how Oracle 21c gives us some seriously advanced tools to handle these massive volumes of data, hopefully with grace and speed. Now, you might be sitting there thinking, why does this matter to me? Well, think about the last time an app felt sluggish. Or maybe an online store just took forever to load. More often than not, the real culprit lies deep within the database, specifically with inefficient queries. These kinds of digital bottlenecks, they lead to slow application response times, high CPU, high memory usage, sometimes system-crippling bottlenecks during peak loads, and importantly, even escalating costs if you're running in a cloud environment.
Yeah, what's truly fascinating here is just how directly that database efficiency impacts, well, not just the end user experience, right? But the actual bottom line for businesses. And Oracle 21c was really designed with these challenges squarely in mind. It offers features that directly address and hopefully ease these critical pains.
Okay, so the pain points are clear. Slow apps, high costs, frustrated users. It's not pretty. But how does Oracle 21c actually equip us to fight back against these digital bottlenecks? Where do we even begin trying to untangle a database performance mess?
Right. Well, we absolutely start with SQL query tuning. That's the foundation. And this isn't just about writing a query that happens to return the correct data. It's about understanding precisely how your database is executing that query. Tools like Explain Plan and SQL monitoring become your sort of X-ray vision. They let you peek behind the curtain at those execution paths.
So it's not just what the query asks, but how it asks it and how the database interprets that request. Is that the idea?
It's precisely. Rewriting queries with proper join conditions, using efficient subqueries, choosing appropriate set operators. These things can dramatically reduce execution time. And this brings up a really important question. How do you make sure your queries consistently use those efficient paths?
Yeah.
Especially when things are changing all the time. That's where SQL Plan baselines come into play.
SQL Plan baselines. Okay.
Think of them like a golden blueprint for how your query should execute. So even if data statistics fluctuate, or maybe the optimizer changes its mind about something, these baselines ensure your critical queries always follow the most efficient, pre-approved path. It basically prevents those unexpected performance dips.
Okay. So it's like locking in that optimal path. But what if the data distribution shifts drastically, or maybe a new type of query comes in that wasn't part of that original baseline? Could a plan baseline, one designed for how things used to be, actually become a bottleneck itself later on? Or does Oracle 21c have a way to adapt?
That's a really good question, and it definitely speaks to the fact that tuning is continuous, right? It's not a one-off. So while baselines give you stability, they aren't completely static. They can be evolved, they can be updated, managed. The key thing is that they provide controlled stability. It gives DBAs the power to decide when and how a plan should change, rather than, leaving it purely up to chance.
Gotcha. Controlled stability. I like that. One of the things that always seems really time-consuming and often kind of reactive in database management is creating and maintaining indexes. What if the database could sort of anticipate your needs? That brings us to something in Oracle 21c that sounds genuinely revolutionary: automatic indexing. This feels like a real game changer.
Oh, it absolutely is. It's a significant leap forward, no question. Oracle 21c monitors the workload, like in real time. It identifies indexes that are missing but would be incredibly beneficial, and then it goes ahead and creates them automatically.
Automatically creates them.
Yes, but here's the crucial part. The detail that makes it so powerful. It rigorously evaluates whether a newly created index actually improves performance before it makes it permanent. This pre-validation step, it isn't just a minor detail, it's really a paradigm shift. It means DBAs can embrace this automation without that constant fear of, accidentally breaking production with a bad index choice. It lets them focus on more strategic things rather than just reactive firefighting.
That before implementing permanently part sounds absolutely critical. Does that mean it removes, almost all the risk for DBAs who want to try this new automation, or are there still scenarios where you'd absolutely need manual oversight? Is it truly set and forget?
Well, set and forget is probably a bit strong for anything in database management, right? But it dramatically reduces the risk and the manual effort. It's more about intelligent automation that frees up significant DBA time. You probably still want oversight for maybe highly specialized, really complex environments, or if you have very unique sort of niche performance requirements. But honestly, for the vast majority of common indexing tasks, it's remarkably effective, really quite smart.
Okay, that makes sense. So, incredibly helpful, but maybe not total autopilot for every single edge case. Beyond this automatic indexing, which sounds amazing, what are some of the, let's say, advanced indexing techniques that developers and DBAs still need in their toolkit for when they need that really precise manual control?
Right. Yeah, there are definitely still several powerful options. Each one is really suited for different kinds of data characteristics and different query patterns. First, you've got your B-tree indexes. These are kind of the workhorses, right? Your go-to for high cardinality columns.
High cardinality, like lots of unique values.
Exactly. Think unique identifiers, primary keys, large sets of distinct values, places where you're doing frequent, precise lookups. B-trees are perfect for that. Then you have bitmap indexes. These are ideal for the opposite. Low cardinality columns.
Low cardinality, so few distinct values, like gender or flags.
Precisely. Things like gender, status flags, yes-no indicators.
Hmm.
Where there are only a few distinct possibilities, they are incredibly efficient for queries that combine multiple conditions on columns like that. So yeah, high cardinality. Many distinct values, like IDs. Low cardinality. Few distinct values, like true-false. Each index type fits its pattern.
Got it. B-tree for unique stuff, bitmap for common flags. What else?
Well, there are function-based indexes. These are essential if you're optimizing queries that have expressions or functions right there in the where clause. Without them, the database would have to recalculate that function for every single row it checks, which is, as you can imagine, hugely inefficient.
Right, recalculating over and over.
Yeah.
That sounds slow.
And finally, there's a really neat trick called invisible indexes.
Invisible? How does that work?
They basically allow you to create and test a new indexing strategy without immediately affecting any current queries or applications. The optimizer just doesn't see them yet. So you can validate their performance, make sure they actually deliver the benefits you expect before you make them fully active and visible.
Oh, that's clever. Like a sandbox right inside your production system. Very useful.
Exactly. It's a fantastic safety net for testing.
Okay, that gives us a lot of granular control, which is great. But how much can Oracle 21c handle on its own, dynamically? What about its adaptive query optimization? How does the database actually adjust itself when workloads shift or data changes?
Yeah, this is another really powerful area. This feature allows Oracle 21c to dynamically adapt its execution plans at runtime. It looks at the actual data distribution and characteristics it encounters right then and there. Features like adaptive joins and adaptive statistics let the queries kind of self-adjust. This leads to much better performance in those unpredictable real-world data scenarios that, let's be honest, rarely match your test environment perfectly.
So it learns as it goes, in a way, adapting the plan mid-flight.
In a sense, yes. It can make adjustments based on what it sees during execution, which is incredibly useful.
Okay. And what about SQL quarantine? That sounds like a protective measure, almost like a digital containment unit or something.
It is, exactly. And it's a critical safeguard for system stability. Think of SQL quarantine as an intelligent circuit breaker for your database. It identifies and stops runaway queries, those queries that might, due to unforeseen circumstances or maybe bad data, start consuming excessive resources.
Ah, the ones that threaten to grind the whole system to a halt.
Precisely those. It prevents one bad query from impacting everyone else. It really protects your business continuity, especially during peak loads. It's a feature that can, quite literally, save your weekend from a production outage call.
Huh. The nightmare scenario every DBA dreads on a Friday afternoon. So this feature is basically a panic button for the system itself, keeping one rogue query from taking down the entire enterprise.
You've absolutely hit on the key benefit there. It identifies and halts those resource-hogging queries before they cause widespread impact. It preserves system availability and performance for all the other critical operations. It's a lifesaver sometimes.
Definitely sounds like it. Now, for those listeners dealing with truly massive amounts of data, we're talking petabytes here, what crucial role does partitioning play in keeping things performant?
Oh, partitioning is absolutely essential when you're managing very large tables. It's fundamental. By horizontally splitting a single logical table into smaller, much more manageable physical pieces, or partitions, queries can become vastly more efficient.
How so?
Well, instead of scanning an entire massive table, the database only needs to scan the relevant partitions that actually contain the data the query needs. When you combine that partitioning with smart indexing strategies on those partitions, well, you can drastically reduce query execution time for these colossal data sets. We're talking about making queries that might otherwise take hours, run in minutes, or even seconds. It's that significant.
Huge difference. So break up the big table, only scan the bits you need. Makes perfect sense. Okay, so we've talked about all these incredible tools and features available in 21Z. Let's bring it back to the listener. Whether you're a developer or a DBA listening right now, how do you actually put all this great stuff into practice? What's the step-by-step workflow when you're faced with a real performance bottleneck?
Right. It's definitely a continuous cycle, because data and workloads are always changing. But typically follows these 6 key steps. 1, identify performance issues. You start by proactively using tools like the Automatic Workload Repository, that's AWR, and the SQL Tuning Advisor. Use them to pinpoint exactly which queries are slow or causing the most pain.
Okay, find the slow ones first.
Step 2, analyze execution plans.
Hmm.
Once you've zeroed in on a slow query, you then run explain plan or maybe use Oracle Enterprise Manager to visualize and really understand its execution path. You need to see exactly where the time is being spent.
Understand why it's slow. Got it.
3, apply query rewrites. Armed with that understanding, you start simplifying your SQL statements. This often means avoiding unnecessary subqueries, making sure you have the proper join-on conditions, simplifying complex logic where possible. Clean it up.
Make the SQL itself more efficient.
4, implement indexing strategies. Based on your query items and the data characteristics you've analyzed, you create the appropriate indexes. Is it a B tree, a bitmap, maybe function-based? Choose the right tool for the job.
Add the right indexes. Okay.
5, enable automatic indexing. For that sustained, long-term optimization and, frankly, to reduce your manual overhead, you enable Oracle's automatic indexing feature. Let the database help manage those indexes intelligently.
Turn on the automated help.
And 6, monitor and tune continuously. This isn't a one-time fix, like we said. You have to regularly analyze your workloads, make sure your statistics are up to date, refine your indexing strategies. It's really an ongoing journey to maintain that peak performance.
A constant cycle of improvement. Makes sense. For you, our listener, just think about the last time your banking app hung, maybe, or an e-commerce site crashed during a sale. It's frustrating, right? More often than not, the culprit is hiding in those inefficient database queries we've been talking about. This knowledge isn't just theoretical stuff. It's what really differentiates a smooth, high-performing application from one that just frustrates users and, honestly, bleeds revenue. So how might these techniques actually show up in your real world? Where can you truly apply this knowledge?
Oh, this knowledge is absolutely critical across so many domains. It's directly applicable and, frankly, highly sought after in the job market. Think about enterprise databases, banking, e-commerce, healthcare systems, places where optimizing queries is just vital for handling millions of transactions, sometimes per second.
High-stakes environments.
Definitely. Then there's data warehousing. You'll use these techniques constantly to speed up those complex analytical queries on vast data sets. You're transforming slow reports into rapid insights the business can actually use.
Turning data into answers faster.
It's exactly. Cloud deployments, too, especially if you're on Oracle Cloud. Improving database efficiency directly translates into significantly reduced resource costs. Every single optimized query saves you money. It's that direct.
Efficiency equals savings. Always good.
Yep. And even in areas like AI and ML pipelines, enhancing data retrieval speed is crucial for quickly feeding data into machine learning model training. It impacts everything from recommendation engines to fraud detection systems, faster data in, faster models out.
Crucial for AI speed.
And let's not forget student projects. This is fantastic practical knowledge for students. Experimenting with these optimization techniques on sample queries and datasets, that's a direct pathway to mastering real-world database performance before you even graduate.
Building real-world skills early. Great point. So when we pull this all together, what does it really mean? We've seen that optimizing database performance, it goes way beyond just, throwing more hardware at the problem. It truly starts with smart, precise query tuning and really effective indexing strategies. It's about working smarter with the database, not just harder.
Absolutely. And Oracle Database 21C genuinely simplifies this whole process with these cutting-edge, intelligent features like automatic indexing, adaptive query optimization, and that SQL quarantine safety net. For students, developers, DBAs, Mastering these techniques provides a really critical edge in handling today's incredibly complex, real-world enterprise data systems. It's about building a digital future that's robust, responsive, and efficient.
Yeah, just consider how critical it is for any data-driven application to not just handle data, but to do it with precision, with speed, with intelligence, making every single query count. What stands out to you listening right now about how these tools empower that level of efficiency and protect system stability at the same time? We really hope this deep dive has given you some powerful, actionable insights into transforming your own database performance.